G'day, a bit of maintenance work on the mill today. It's given me beans. One of the lights I use on it is started to flash. I managed to find a couple of lights for a reasonable price, so I'm going to put those on there. I've also got some arms which I've been meaning to put on for quite some time to hold the lights. And when I look at the power supply I need, because it's a different power supply of course, it takes an IEC plug, which is one of those ones, rather than the 2-pin Euro plug that is on the mill at the moment, so I've got to change that over. This is the current light I have on the machine. That's just a bracket there which goes onto the dovetail for the overhead boom when it's used in horizontal mode. It's a bit annoying because I've got to take this off every time I change over, but it's one of those things that you soon get used to doing, and it'd be nice to leave it on, but I don't really know where there's anywhere I can drill in here where I'm not going to be breaking into a gearbox or a bearing or something like that. So at the moment, that's how it is. So what I'll be doing here is basically chopping that and putting a piece of flat on there, and then bolting the arms that I've got on here and attaching the lights to the end there. Things are literally going backwards here at the moment. I've got a disc of material and I want to make a hat section out of it, and so I've cleaned up the outside where the rim is going to be. I need to take that diameter in to 55, but the step on my chuck here is 1/4 inch and I want that 5mm. So what I've done here is I've got some split pins, and just these were the right size and all that sort of thing, and I've taped them to the back. I'm just using those as a packer to push that out, and that will give me a little less material to hold on to, but it should be good enough that I can take some gentle cuts, because this is just a bit of nylon. And the other benefit is that the tape is on the machine surface, so I'm not going to do anything too terrible. The next thing is getting in there. Now, a standard tool, I can't actually get in there very easily. This is just the normal tool I use, and it stops. It doesn't get in there as far as I want. So what I'm going to do is run the lathe backwards. I've got a boring tool, and I'm going to come in here and use that to take this down to the diameter I want, and the combination of the pins to push this out should give me and the boring tool should give me a 5mm flange there, 70mm diameter, and then back down here to 55. I've put a recess in the front of this, which is just big enough to take well, strictly speaking, I believe it's a plug, but we'll call it a socket just for simplicity's sake. I have to cut a rectangular piece out of there. I also need to put a couple of mounting holes for mounting this on the panel. So I'll do that. The base I've got here is 3mm thick, and that's probably about as thin as I'd like to take it. This style of plug is a clip-in arrangement, and it's designed for 1.2 thick material. So I was thinking about putting a metal plate on the back of this, basically going straight through, putting a metal plate on and then clipping that in. But I think what I'll do instead is I'll put the right size cutout in there, and then I'll actually trim back these clips. So that's my plug holder machined out with the 2 mounting holes plus the square recess. That sort of information is on the data sheets you get for these things, so if in doubt, consult the data sheet. I've taped up the electrical sides of both of this because I don't particularly want swarf getting in there if I can help it. I'll still give it a good clean and all that sort of thing, but what I've got to do is just basically come along and make that 3mm and then flip it over and make those 3mm. I've run across the top of those clips with a milling cutter. I didn't bother going all the way through. Some examples of these things you get have got a step like that, and it's so that the clip doesn't get pushed out too far. I'm fine with that. What I did have to do was get a screwdriver in and just make sure that that wasn't pushed down as I ran the cutter across there, and I also had to grab these a little bit with a pair of needle nose pliers just to try and keep them from really flicking out the way. But moment of truth time. Clicks in both sides, nice and solid. So that'll do for this bit. These are the two arms that I've got to attach my lights to. I made these up a couple of years ago now. They've been sitting under a cloth on the bench, just waiting for some action, and they're starting to actually pick up a little bit of surface rust, so I probably need to take them apart and clean them as well as adjust them. Now these are based on this sort of thing, and in fact what I did was I actually took this apart. I bought it, was told it was a brand name unit, discovered it's actually a copy, and thought, well, if it's a copy I can take it apart without any problems. So I'll take this apart in a moment and show you how these things basically work. But what this enables me to do is have that secured to the mill, and then just by loosening one knob I can adjust the lamp to wherever I want it. So how do these things work? Well, it's another one of those products where you think, gee, someone must have been really clever to work all this out. But what you've got there is a ball joint in a cup, and there's a plunger that pushes on that. And then on top of that there are some shims just to get the adjustment right. As you can imagine, something like this, if you want to get everything spot on you can, but it's far easier just to do a little bit of shim work. Okay, that's the arm there. In there's a ball-nosed, what would you call that, slug, and then there's an arm that pushes. So that goes in there like that. And you can see the ball is just coming out of the hole there, and then that screws on. So when pressure is applied to that ball, that's transferred through to the cup, which pushes on the ball and locks everything up. Now how the pressure is applied to the ball nose there is the clever part, because in the ends here there's a bush with, I don't know what you'd call that, an offset socket. And what happens is that when the knob gets tightened, that pulls the bush over, and that ramp in there pushes on the end of the ball and pushes it down. And there's one on this side and there's another one on this side, same thing, so that you tighten one knob and it pushes both of the arms out. And that's one of the reasons for the shimming, trying to get both sides lined up accurately. Difficult, so you use some shims just to take out the play. So that's how they work. When I first made these, I made both of these threads M10, and that was just a simple scaling thing from the small version that I was using as a model, and that was fine. I thought that was probably a reasonable size thread, but the brackets I have for lights are M8. I could make up new brackets, but these brackets are perfectly fine, and they've also got this interesting little feature which basically stops the nut from rotating. So that's a handy thing to have, and I've got no great desire to get rid of that. So what I'm going to do is, instead of taking these out for an M10, I'm going to change that thread and make that thread down to an M8. Now that's a bit of a problem because there's nowhere to grab it. So what I've got is a split collar, and that'll go in there down here. I can take this down to 8, put a thread on it, or at least start a thread, and then turn it around, similar sort of collar, take that down. I'm going to have to reshape the ball on the end, but that's all right because I've been looking for an excuse to do that. This is one of those setups that I've always wanted to try but never had an excuse or an opportunity or basically even had the bolts for it. So I've got my ball mounted up there. I've marked up the surface so that I can see where the cut is. But the idea is that because this head is inclined on an angle, I'm going to get a circular path there, and as I do that, if I'm rotating this, what should happen is that should give me a spherical surface. These were made on my ball turning device on the lathe, and they're okay, but because I've taken this shaft down, there's a bit of a step there, and I've also noticed that when I sort of tighten them up, there are tight spots and there are loose spots, and so I want to try and even that out. To explain the geometry of what we're doing here, this is my ball joint with the M10 shaft. The boring head is swinging a circle which goes from that point to that point, and so that's what, as this is rotating, that's what's generating the spherical surface. Now, a couple of points to watch here is, if you don't have that right on your center line, you'll get a nub there. Okay, that may matter, it may not, depending on the size of the nub. Similarly, if you don't have the angle right, you'll chew into your shaft. So you need, well, I drew this up on CAD, just 2D drawing package to get it right. And the last thing that you should note is that the diameter of the arc, or the diameter of the circle that you're swinging here, is not actually the diameter of your finished sear. It's slightly less. I fell into that mistake by thinking that, yes, I adjust that up to so that the cutter is touching on the biggest point when I've got that turned to a 15.88 cylinder. No, that's not quite right. It needs to be slightly less than that, and so setting up the first one might be a little bit of trial and error. There's the first done. There's a couple of scratches there from the tool. I've taken this back to the lathe and given it a bit of a polish and a clean up, but that's all good, and that sits nicely in the cup. Not quite sure about the back there. I may not have had that meeting up quite enough, so I can feel a slight nub there, so I just give that a swish with a file. But other than that, you know, that seems to work. Now, for those of you who want to try this at home, I've got the axis of the spindle on the axis of the part. So this chuck is just bolted on here. It's not quite central, but that's okay because the ball is. So I've got that sitting there. I'm recentering this ball because I want to have another go at cutting it. It's not quite right. Just thought I'd show you this. I want to line up get the ball centralized. So I've got it centralized using an indicator on the rotary table, but I now need to center or check the center of my axis underneath it. Now you can use this with I'm using the microscope here, but you can use this with a probe or whatever, but rather than trying to find a spherical surface or a curved surface, what I've done is I've just got an angle plate. I've got it resting against that surface, and I'm going to indicate off the angle plate. And what that'll do for me is I'll do that there, then I'll turn it around, do it on the other side. Provided I've got that angle plate square, I can then work out where the centre of the axis should be. So going through the whole setup here, the socket plugs into the plug, or the plug plugs into the socket. Up here I've got a sheet metal bracket which the power supply just sits in. Nothing special there, that'll just slide out. It's aluminium, which I've discovered this thing does get a little bit warm, so that's probably a good thing to help dissipate some heat. From the power supply, the 12 volts then comes through to here. Over here I have it's just a plastic junction box, so I bring the power supply line in and then the two out to my lights. That's a little ferrite, and that's important to keep on there, because otherwise you'll have interference with televisions and things. So finally there's the light, ball joint, fancy arms. It will position just by loosening that off. I can move that over to there, say. And there we go. So thanks for watching, and we'll see you for the next one.